Okay, so we've got a second question here whereby we're given the curve y equals x squared minus 4x plus 7, okay? And in part A it says find the equation of the tangent to C at A, okay? Now A has got this coordinate 1, 4, okay? So just like in the previous example, the first thing we would do is determine the gradient function. So we differentiate, so bring the 2 down, so we get 2x. And then minus 4x becomes minus 4 when you differentiate that, okay? And of course the 7 is a constant, so it becomes 0. So here's my gradient function, and then I can work out the gradient at A, okay? So at A, of course, we've got the coordinate 1, 4. So dy dx will equal to 2 times 1, take away 4, and that works out to be negative 2, okay? So this is the gradient of the tangent, yeah? Okay, so take note of that, the gradient of the tangent. So we've got that there. So we've got what we need, haven't we, to answer part A. We've got the ingredients, we've got the gradient, and we've got the coordinate. So just to remind ourselves then of the situation, okay, so if I was to draw a sketch of a curve and then at the point A, of course A has got coordinate 1, 4, yeah, then you would need your tangent, so that would be a line that sort of goes the same slope as that curve and just touches at A there, so a rough sketch there. So we know the gradient in this case is negative 2, okay? Obviously I haven't drawn it sort of to scale in this sense because I've actually got a positive gradient here on my sketch, haven't I? But ultimately it's a negative gradient. That doesn't matter, okay, because it's just a sketch to remind us that we need the gradient, which is negative 2, and of course the point then of A, which is 1, 4. So my equation of the straight line, so my equation then of the tangent will be y minus y1 equals mx minus x1. So it'll be y minus 4, okay, because my y1 is 4. My tangent gradient is minus 2, and then my x1 is 1. So I'm using that point and I'm using the gradient. So there you go, okay? This is a case then of simplifying this. So expand that bracket, minus 2 times x is minus 2x, minus 2 times minus 1 is plus 2. So you could rewrite that maybe as y plus 2x equals 6. And there's the equation of the tangent. Now for B, for the normal, okay, we need to go back to our sketch, okay? You just need to appreciate that the normal, okay, is always at right angles, okay, to the tangent, okay, always. So if we have got the tangent and we've got the gradient for it, we could then use that to help us to determine the normal equation. Because ultimately, when we've got the gradient of one, we can work out the gradient of the other because they're perpendicular to each other. So if you remember the rule we learnt in coordinate geometry, m1, m2 is equal to negative 1. Okay, so we know the gradient of the tangent is negative 2. So it's just a case then of plugging that in to this formula to work out the gradient of the line that's perpendicular. So minus 1, if you take that minus 2 over, it becomes a half. So this would be the gradient now of the normal. Okay, and what's good is with the gradient of the normal, because I've got that to be a half, I know it goes through point A. I can then quite simply work out the equation, just like before, using point A, but this time using the gradient of the normal, which is a half. Okay, so when I've got that then, I manipulate this, I'll take that 2 over the other side and multiply. And then if I expand, 2y minus 8 equals x minus 1. So you could maybe write that as 2y is x. Doesn't matter which way you put your letters, as long as you simplify it correctly, plus 7. Okay, so that's my answer there for the equation of the normal, and make sure that you annotate that there to explain what you worked out, and we're done.